talk about the sort of limitations of what I'm trying to do today. As I said, it's England. We're mainly looking at the GCSE in computer science because there's most data on that, but I'm going to try and link to ICT in particular because that's what it did replace, and some of the other subjects too. There's very little 2020 data because the data set the government should have released, they didn't for some reason. I'm not sure why. So we do have some data on 2020, but it's mostly up to 2019. Which might actually be a good thing in terms of looking at computer science, because unfortunately computer science has not had a very good 2020. I'm going to be looking at, say, the reasoning behind the curriculum change, some of the policy decisions, and we're going to get you guys starting to question if that was a good idea or not. And at the end, I'm going to talk about some of the questions that I'm going to be answering over the next couple of months / years, which I think jump out of this data. Just a word of warning, you're about to see quite a lot of data. I'm going to try and talk you through a lot of graphs and tables and things like that, and I'm trying to build a picture. I'm not trying to claim here that this is because of this. I'm just trying to present the data as a means by which we can shape an argument, which definitely needs a lot more exploration. I've got a data set here, but there's a lot more work that needs to be done in computing education. So, to give you a bit of background, you see the first computing qualifications first computers appearing in schools in the kind of 66, 68 period. Many of you will be aware of the computing kind of revolution, they like to talk about it, kicked off in 1982 with the BBC micros. The BBC micros was introduced in 1982. There's a lot of people that say that this started the computing revolution in England. Not so much data for that, except used the computers back then, actually set up various computing firms. And for example, you might have heard of the ARM company. ARM is the biggest chip developer in the world, and that was actually came out of the BBC Micro project. So this was quite a big initiative to help kickstart the kind of the industry, but the impact of schools is a lot less clear. You maybe had one computer in a school, or it was a computer sat in the corner of the room. Trying to get research on how well these computers were used in schools is actually quite hard to come by. So we have a bit of precedence of trying to teach computing in the 1980s, and then we try and repeat this again back in 2013. So it's quite important to understand that 1982 was a big deal for the English computing education system. But this model of computing slowly mutates into this thing called IT. So computing is about how computers work, it's about how to do computer programming, and then you get this movement towards IT, which is more about the applications, the implications of computing on people's lives. 1995 sees it as a distinct national curriculum subject, and then this curriculum document has several iterations. It changes its name from IT into information communication technology. So you have this kind of concept that computing isn't just about using computers or understanding how computers work. It's about being able to communicate with them as well. But there were a lot of people who were quite unhappy with how computing, also how ICT was going in schools. And you have the Foundation of Computing at Schools group in 2008, and then 2011, quite a pivotal moment. You've got Eric Schmidt, the then head of Google, delivers the McTaggart lecture up in Edinburgh, talking about how Britain's thrown away its computing heritage and we don't even have computer science in schools. And from that, a whole kind of flurry of reports come out, and the government does change. And one of the biggest reports was the Royal Society Shutdown and Restart, and they obviously chose to reboot the curriculum with this model here, which is computing. This is the subject that we currently have in schools, being a combination of computer science, IT, and digital literacy, where computer science is, to use Miles Berry's terms, the foundations of how computing works. So the underlying maths, the underlying logic, the underlying theories. IT is the applications of how computers can be used in the world to solve problems, and digital literacy is the implications of how computers can actually and impact us as individuals. And that was what was recommended very roughly by this Shutdown and Restart document. And then Michael Gove comes along in 2014 and is quite critical of ICT. University acknowledged as unambitious, demotivating and dull. ICT has to go. So this use of computers, this focus of use of computers, which has been in a discrete curriculum subject since 1994, was said we've got to get rid of this. We have to have this new thing, computing, with this focus on computer science. It says universally acknowledged as unambitious, demotivating, and dull. We're going to question this a little bit later because I think that's a bit too much of a sweeping statement, and there are some myths which we have built this computing curriculum change on, and this is, I suppose, this is one of them. And it says ICT used to focus purely on computer literacy, teaching pupils over and over how to word process. Again, we've got these overgeneralizations, and actually programming was part of the old ICT curriculum. It's just not a very large part of the ICT curriculum, wrongly or rightly. So this is what the Royal Society suggests. Computing is, as I've said, digital literacy, information technology, computer science, and you should be seeing these almost equally represented. But what we are seeing, certainly now, is this kind of heavy focus on the computer science element, and a lot of these things kind of falling by the wayside. And I'm going to talk a little bit about that later. So a bit further onwards, we stopped at 2013. Let's go to 2014. We have the new computing program study developed by the DfE and a range of other people, including myself. ICT was disapplied. We then get this interesting decision by the government to renew the ICT/IT A-level and GCSE. So going back to this model here, we don't have a qualification over here anymore. We only have a qualification over here for GCSE and A-level. There are other qualifications that kind of meet this space, but they are not GCSE or A-level qualifications anymore. You get the BBC trying their hand again, putting the microbit into schools, and you get the announcements and the implementation of the NCTE, which is the National Centre for Computing Education, which is, I know we've got a few people from that organisation here today, upskilling 8,000 teachers. So some of the things inside the £84 million was upskilling 8,000 teachers, and also getting computer science GCSE into every school. And again, this is, this word computer science is coming back. It's the National Centre for Computing Education, but you see some of the focus, which is governmental here, is trying to implement more computer science in schools rather than the old IT. And you might argue that maybe we didn't need to do that, but again, I'm going to let you make your own decisions on that at the end. Okay, and then obviously the online learning crisis, which is where we currently are, with children trying to learn at home, and this need for digital literacy amongst teachers and students too. So that very roughly is our kind of potted history of what's happened over the last, 60 years. Now, I'm going to look now at some of my work and other people's work on what has been the impact of this curriculum change. Now, the impact is maybe the wrong term here, because we are looking at, I suppose, trends that coincide with what has happened. And one of the most worrying trends is this one here. And what you're seeing here is you're seeing actual numbers of hours, thousands of hours taught at each of the key stages. This exists for every subject. It's put together by the government every November. They do a snapshot of what's being taught in 1 week in November, and they start to estimate how many hours of each subject's being taught. And as you can see, you've got steep declines for each of these key stages. So Key Stage 3's lost 28%, 54% for Key Stage 4, and 43% for Key Stage 5. And these are actually kind of core numbers of hours. This isn't about numbers of students taking what or which students are taking what. This is just core numbers of hours of computing taught at each of these key stages. And this is hugely worrying that we have the curriculum change which takes place about here, and actually it's just been decline for each of these measures since then. And I did some work on the 2019 data set, and we calculated it was about 9 minutes of non-GCSE computing per student. If you're not doing a GCSE in computer science, or it was ICT back then as well, then you are likely to be getting 9 minutes of general computing education each week, which for most students likely means no computing education for anybody in Key Stage 4 if they're not doing a qualification in that space. And if you've got a 3-year GCSE, it might mean that there are some students, and we're going to see which students that impacts, particularly girls, who might not be getting any computing education from the age of 12. If they finish computing in year 8 and they're born in August, they might not have any computing education from the age of 12. So this trend is hugely worrying. We've seen a huge loss in hours. Looking at the actual number of qualifications taken, it paints a similar picture, and it's this here. So the red line down here is the computer science GCSE, which was actually introduced a little bit earlier, but the first year that the JCQ reports qualification numbers is 2013, and it's going up here, and you can see there's a very slight decline between 2019 and 2020. So either computing's leveled out, or it is in a very slight decline, and we can start to talk about that a little bit later. You've got the green line is ICT. ICT is gone. 2019 is the last year it was examined. There's nothing in 2020. And overall at the top, you've got this total qualifications. There are a lot of vocational qualifications for computing. One of them was something called ECDL, which you could basically learn in a week, and it was worth a whole GCSE. You can see why schools might might have chosen to offer that, and that disappears in 2017, and then you see this kind of steep decrease. I've got a grey box around this because the data on actual number of qualifications is a little bit harder to come by than, say, number of hours, and there are there are data sets which do contrast with each other, and they're not telling exactly the same figures, but I think this is probably generally true, and that's a 50% reduction in number of qualifications since 2007. So we've seen a steep decline in number of hours, which maps the steep decline in number of qualifications as well. So which school? So I'm going to focus now a little bit more on the computer science element, because this is the flagship of the government and what they're trying to do with computing in schools, certainly at the key stage 4 level. And what you see here, I'm just some terminology that I'm using. I've got percentage all, percentage possible, and reach. So this is the percentage, or percentage possible. So this is saying 16.3% of all students in the country. Sorry. Let me start again. Percentage all. This is 13.2% of all students in the country were sitting a computer science qualification in 2019. 81.1% of the reach means that 81.1% of students were in a school where computer science was on offer. That does not mean they were allowed to take it. It doesn't mean that they, even had the choice to take it. In a second. And then finally, possible is out of the 81%. 16% of them actually did take it. So out of those who could possibly take it, 16% of them did take the subject. And actually, you can see there's slight decline there. And we are missing here the 2020 data, which the numbers are, I think it's 73 or 75,000. So it's gone down a bit, unfortunately. Now, as you can imagine, it's not just saying, OK, all 81% of schools across all different ways of, breaking schools down into groups offer computing, computer science, I should say. There are different offerings depending on which school type you're looking at, and I'm breaking it down here by grammar schools. Grammar schools have the kind of 90%, 91% I should say, of students in grammar schools are in a school where computer science is on offer. Just checking there's no, okay, good. And comprehensive, it's lower. You might find it quite surprising, but in independent schools is a lot lower than that. So we can look at these in terms of trends across the years. The green bar here, green line, is your grammar schools, and you've got nearly 25% of students in schools where computer science is offered are taking it. So a quarter of students in grammar schools where it's being offered are taking it. And you can see the independent schools are not that well represented at the bottom, but they are catching up. Certainly in terms of possible students. And we're looking more to do the IGCSE, or they don't value computer science in the way they may value other subjects. It's a bit unclear as to why this is happening. And as I said, the 2020 figure will be down, but I'm not sure who that's impacting on. It might be that state schools are struggling to recruit for it. It might be that grammar schools have seen that it's not actually that useful. We don't know what the 2020 figures is going to tell us yet. So who is the change impacted? Well, I'm going to focus on 3 areas. I'm going to focus on girls and boys. I'm going to focus on ethnicity, and I'm going to focus on poverty. And just to kind of save you having to even watch this, just to sum up, we've seen a huge decrease in girls getting any form of digital education. We've seen a decrease in black students getting any form of digital education, and we've seen a decrease in students from poor backgrounds getting any form of digital education. And obviously, all 3 of these areas are hugely concerning. But I'm also going to look at some combinations of these groupings too, which might make for more interesting stories to tell, maybe in areas of research. So looking at boys and girls, well, these are the headline figures that if you are watching the press about computing education, you'll generally see stuff about gender in computing or sex in computing. And as of 2020, you're looking at about 22% of the GCSE cohort are computer science cohort are female, 15% of the A-level cohorts are female, and these numbers have actually gone up. It was 20 and about 10%. So it's good news. We are seeing an increase in girls taking these subjects. An increase in percentage of these subjects being female as well. But it doesn't bode well for, I suppose, the next couple of years, because we're getting rid of the ICT qualification. We got rid of the ICT qualification, and you had with the old ICT qualification, you had about 43%, and a lot of the vocational courses again would be in the kind of the 40-45% range. Girls were more likely to take more IT, ICT, digital literacy style qualifications than they are computer science qualifications. So it goes without saying, really, if you shift the focus towards computer science, pretty obviously you're going to see fewer girls taking a computing qualification. And remember that computing is a combination of computer science, IT, and digital literacy. So girls' numbers, well, again, because the data is a bit weak here, this is something I need to repeat. You can go and find out what percentage of girls in any given year was sitting any digital qualifications, and in 2014, sorry, it's about 43%. It drops down to about 34%, and that, just to let you know, this little graph here is only telling the story for this part of the graph here. So if we see the decline in vocational qualifications, if we see getting rid of ICT, I imagine that this figure for 2018, 19 and 20 is going to be significantly lower than what we're seeing here. But you can already see there's a huge difference in any form of digital education. It's not just computer science, it's any form of digital education. So we need to keep an eye on this, because it looks likely that there are a lot of girls in schools getting no education around computing from Key Stage 3, from the end of Key Stage 3 onwards. Okay, so who can take GCSEs? Well, we can now go and look at different genders of school. We've got boys' schools, girls' schools, and mixed schools, and you can see here. Well, it's not just about being in a girls' school that you don't offer computing, because grammar schools for girls do offer computing, and you've got 76% of comprehensive girls' schools offer computing, while it's only 89% of 76% of girls in comprehensive girls' schools can sit computing. They're in a school where it could be offered, while it's 89% if you're looking at a grammar school for girls. So there's a huge difference, a huge disparity in the offerings here. And one of the most worrying things that I've come across recently is this figure, which is the drop figure. And you find that in 2017-18, 19% of the schools who were offering it in the year before weren't offering it then. So you've got a huge kind of churn of schools, comprehensive girls' schools, who are offering it one year, they're not offering it the next year. We don't know why, and it's likely to be something linked to staffing. It's potentially they can't staff it, they can't get the staff to teach in the girls' school to offer this. They can't, maybe the girls don't want to do it, maybe they can't timetable it, and maybe it's something to do with results. We're going to talk about results in a bit, about how stupidly hard computer science is for students, particularly girls, actually. So, poverty indicators. I'm going to be using two terms here. One of them is pupil premium, which means a student has received free school meals within the last, let me get this right, the last 3 years. And you've also got IDACI, and IDACI is a much more nuanced indicator of poverty. It's to do with the poverty of the area where somebody lives. So you can use IDACI to find out how poor the area is where their house is. That postcode, every postcode has an IDACI value, which tells you how poor that area is. So IDACI is probably a better indicator of poverty than pupil premium, but we're going to be using both of them. So, it may not surprise you, but schools serving poorer communities are less likely to offer computer science. This graph here, it takes all the schools in the country, which are grammar schools and comprehensive schools, and what it does is it separates them into 10 bands, with the richest band being number 1, the poorest band being 10, and it looks at the percentage of those schools which are offering computer science. And you see 2/3 of schools in the lowest band offering it, and you see 93% of schools in the highest band offering it. We might not be surprised, but this is not the pitch that you saw with ICT. So depending how poor the area you are going to is, so the area that you're living in is, or the area that the school is based in is, then you're less likely to be even able to sit a computer science qualification, which is hugely worrying for kids, with the social mobility agenda for the government and so on. And we can go and look at the genders here as well. So what we did here was we split all students in where schools were offering computer science and ICT. So they had to be in a school where it was being offered. We then split those students into 10 buckets. So the richest students are on the left-hand side, the poorest students are number 10, richest students, poorest students. We then split it by gender, and we looked at the likelihood of them taking computer science or ICT. And what you see is the richer the boy, roughly, it's not a great trend line here, but the richer the boy, the more likely they are to be taking computer science. And then, rather surprisingly, the poorer the girl, the more likely the girl is to be taking computer science. So we used a bit of logistic regression to test this as well, which I'm going to talk about in a second. So the richer the boy, more likely to take computer science. The richer the girl, the less likely to take computer science. This is not the picture that we saw for ICT. ICT was actually pretty representative of the population. You can see the kind of the significance lines here, the error lines on this trend line, and actually it's not hugely significant, these lines. It's a subject which was taken by the general population, really, in terms of ICT. Computer science is a lot more elitist. Except, let's say, amongst girls, which is quite interesting. So the model down here, we looked at the IDACI score and we looked at it as a predictor for females taking computing, and you find that it's a significant line. It definitely looks like a significant relationship there. Unfortunately, the R-squared value, the effect size is incredibly small for this. There are other factors at play. It doesn't mean that if you're poor, you're definitely going to be taking computing, and if you're rich or not. There are other factors at play. It might be something to do with the school type. It might be something to do with ethnicity, and we need to build a better model to explain this. But in terms of the descriptive data, the poorer the girl, the more likely they are to be taking computer science. So there are selection criteria. One thing that we have discovered is boys and girls taking computer science generally have quite strong maths backgrounds, and this is something that matches as well discussions with teachers, that you see computing being limited in a school, and they limit by maybe there aren't enough teachers, or the timetabling is up to it, or they're worried that they're going to get rubbish grades, so they select students. They have selection happening in schools, in many schools, based on mathematical ability, and you're going to see in a bit how how bad a choice this is of subjects in terms of trying to find out if students are very good at computer science, because we think that maths is related to computer science. The data does not actually suggest that. And also, I would say it'd be quite hard to find many other subjects where you have selection criteria. It is a very worrying trend. So looking at ethnicity now, these are only up to 2017. Again, this data needs to be updated slightly, but you can see that you have, computer science, you've got nearly, well, actually over 1 in 4 Chinese students, ethnic Chinese students were taking computer science in 2017. That figure might well be higher. The lowest represented group are amongst black students. It's a bit more, the lines are certainly closer together for ICT, but ICT very, very popular with Asian students, and again, quite popular for computer science as well. But amongst black students, they are the worst represented group. We can combine ethnicity, and we can combine poverty factors. So going back to our IDACI things, so remember, IDACI is about how poor an area you come from, how poor an area that you're living in. And we can see that actually for the girls, we know that poorer girls are more likely to take computer science, but that trend is probably, well, largely explained by poorer white girls. So it does seem to be more appealing to poorer white girls than it does maybe poorer girls in other ethnic groupings. And we don't have, as far as I'm aware, any real research here on working class white girls and why they're taking computer science. It is a very interesting trend which does need a lot more exploration. So how do students do it in computer science? I'm going to talk here, and this has some implications for kind of the wider kind of STEM research too. And one of the reasons that we wanted to have computer science is because we thought that ICT was really easy. We thought that students were being taught stuff they already knew. We thought it was something which everyone went and got an A or an A star at. And this is further from the Royal Society report saying we want to have a more rigorous and challenging computer science course, and actually we have certainly achieved that. If one thing has been done, it is that. We certainly do have a more challenging computer science course than the ICT course. But I'm also going to show you that the idea that ICT was easy isn't actually based on the data. So excuse this huge grid. What I've done here is I've taken every subject. For every student sitting in that subject, I compare their grade in that subject against their grades in other subjects. So let me just show you an example. If I go to ICT, I've got all the students sitting ICT. I then look at their grades in ICT and I compare it to their grades when they're sitting in other subjects. So this box that's been highlighted, these are all the students who are doing ICT and computer science at the same time. And on average, the students doing ICT and computer science at the same time got 0.79 of a grade more in ICT than they did in computer science. You can look at this for any of the subjects that you want to go and choose. So let's go to geography. So it would be all the students sitting ICT and geography at the same time. They got a third of a grade, or 0.31 of a grade more in ICT than they did in geography. And if you're looking at your trends, a line which is pretty dark bluish, dark green, these are your hard subjects. So for computer science, 0.96, minus. Computer science students sitting computer science at the same time, they got the same grade. Of course they would. It's negative for pretty much everything until you get to French and German. Okay, so computer science students generally get a lower grade in computer science on average than they do in every other subject other than German, French, and I think it's Spanish there too, or maybe not Spanish. But anyway, it's just the languages. The languages are the only areas where they get higher grades in computer science than those subjects. And we see maths here. So actually, the subject where students get a lower grade in computer science by the most, the largest value is maths. So maths is the worst predictor, according to this graph, of performance in computer science. The worst predictor, worse than any other subject. And you would expect them to be quite close. Now, I'm not saying that computer science is inherently difficult, and probably what's happening here is the exam boards have the wrong grade boundaries. If you just change the grade boundaries, you could change the color of this line, and obviously balancing one subject against another is very, very difficult. But that's exactly what they've done for modern foreign languages. They've gone and they've looked to see how hard the qualifications are, and they've changed the grade boundaries to make them easier. And that's what needs to be done for computer science, because at the moment we've got a very limited number of people doing computer science, and when they do it, they do really badly. So they're going to think that they're rubbish and they won't do more computer science. And this is something which needs to be urgently rectified. Okay, so I want to also kind of compare how girls are doing. Now, just to kind of cut to the chase, girls outperform boys in computer science. So it's not the fact that girls can't do computer science. They definitely 100% can. They get higher grades than boys in computer science, but they get higher grades than boys in pretty much everything. So what I want to do here is I want to look to see how kind of relatively hard girls find it. To find out, how they're doing compared to the other subjects. We're looking for relative achievement. I want to find out if boys and girls of similar attainments in other subjects are getting the same sort of results when they're doing computer science. And other subjects too. So the model I'm using is roughly this. So let's imagine you have a student doing 3 subjects, maths, history, and physics. So they get an A, a B, and a C. I'm using 2016 data here. They get a C grade in computer science. You can see that the average attainment is 7 plus 6 plus 5 divided by 3 is 6. So they do 1 grade worse on average in computer science. That's the model that I'm looking at here. And what I can do as well is I can build a general linear model on this. So I'm looking at the attainment in the subjects, in this case computer science, given the average attainment in other subjects and gender combined. Okay, so how well does the average attainment in other subjects predict how they're doing in this when it's combined with gender? And this means that I can look to see what does gender mean when I control for the average attainment in other subjects. So when I find 2 students who are pretty much the same level in terms of their attainment in other subjects, they're both B grade students. What does gender explain then in terms of how well they're doing in computer science? And that means I can roughly compare students of the same ability. I'm saying that with quotation marks. It's not really ability, it's attainment, which are different things. Here we go. With computer science up here, and I'll actually just read this out before I make any mistakes with my data. When a boy and a girl have the same average grade in other subjects, the girl would get 0.25 of a grade more in English language. The boy would get 0.31 of a grade more in computer science and 0.46 of a grade more in maths. So it's this line here that you're talking about. Okay, so we're looking to see what does gender explain? What's the explanatory value of gender when we control for ability in other subjects? And you can see that girls and boys of similar attainment profiles in other subjects, the boys will get 0.31 of grade higher in computer science. For ICT, boys and girls get pretty much the same thing, and it's not even significant. And you can do this for all the subjects, which I have done. And you can also see that here that the girls do get a higher grade than the boys in computer science as well. And the other thing is the effect size is pretty big for this. So this model goes a long way to explaining how how students perform in computing. So if I go and plot this, it tells me something about, I suppose, STEM subjects in general. Now, if you go and plot this this model, what S is talking about? It's talking about the impact of gender. So positive values are telling us that that boys are going to be doing better. Negative values telling us that girls are going to be doing better. And you've got two groups of subjects. The group up here, you'd call your STEM subjects, really. You've got your maths, your physics, computer science, science additional, science core, physical education, chemistry, biology. So these subjects here are telling us that amongst these subjects, boys will generally perform better when you control for attainment of the subjects. So these are girls and boys of similar achievement profiles. The boys will do better at STEM subjects. And down here, you've got what would say would be, I suppose, non-STEM subjects, the arts and humanities. And these subjects, you're seeing that actually girls do better. So girls and boys of similar grade profiles, the girls will do better in these groups down here, which is hugely worrying because it means the exam system is reinforcing the gender stereotypes that we actually see in society. And when girls and boys do take subjects which are not linked to their gender stereotype, they're going to be on average doing quite badly at it, and then probably not choosing to do those subjects much more in the future. So in summary to this section, I'm going to go back in a second to look at the curriculum change. But digital education in schools has decreased substantially since the introduction of the new curriculum, which is hugely concerning, in particular for certain groups. There are serious disparities in access to the GCSE computer science qualification. The computing qualification changes in England do not appear to be equitable for girls, working class and some ethnic minority groups. The exam system tells girls and boys, to a lesser extent, they have strengths elsewhere when you're looking at computer science. And then, there's a big question here is what does it mean for self-efficacy? If a girl does really badly at computer science, will they want to go and study it again in the future? Probably not. If you're looking at you generally study what you think you can do well at. And so with self-efficacy theory, it's it's potentially a really big impact on how students select their subjects. If computer science is very hard, you're not going to see more people wanting to do computer science. And the majority of girls still outperform boys, so it's a big caveat here. And we've got the new computer curriculum. There's only been around since 2014. I keep saying this, and maybe it's 6 years. It's quite a long time now. But we've got a lot of money being thrown at with the NCCE and so on, and hopefully things will change in the next couple of years. But it will take, I think, Ofqual to come and change the grade boundaries a little bit, and a lot of work to try and engage females in this. And I would also argue that reintroducing some sort of IT qualification at GCSE and A level would really help as well. So let's return to the question from the beginning. Was the curriculum change a good idea? With the data you've seen, I'll let you make your own decisions, but I'm just going to look at some of the literature behind the curriculum change. You had the curriculum change quite unusually. I think it was one of the first subjects to be renewed, and you have some academics being slightly concerned that Williams here, global commercial technology companies have gotten closer to education policy making. So the curriculum was helped draft involving people from different technology companies, and the whole reason we have a curriculum change is because the Taggart lecture, you might say. So you've got global technology companies coming in and actually starting to shape what's going on. And this is the Hope and Livingston report, the Nesta Next Gen report. So they're saying, well, we need to have rigorous computer science programming skills, which high-tech industries like video games and visual effects need. So there's this push here for the commercial impact of the curriculum change rather than necessarily the needs of the students. You've got Williamson also saying that schools without fully trained teachers could just drop computing altogether, and we haven't quite seen that yet in terms of computer science qualifications, or maybe a little bit with girls' comprehensive skills. But we might be seeing that academies are not being held to account by Ofsted for teaching computing at Key Stage 3 and Key Stage 4 to everyone. So therefore, they just get rid of it. They focus on their maths, focus on the science, the kind of big ticket subjects, which will get them better grades compared to other schools. And then you've got Rudd saying, worried that, sorry, can you move, please, pointer, wherever you are. There you go. Worried that computer science is going to become an elitist and selective subject. And I would argue that, yes, we have seen a move towards that from ICT. And then, the point I've been trying to make is we can't just treat computing as computer science. We've got to think about all the other parts of computing, other digital skills. And Lark's talking about academically weak and vocationally useless prevailed. So this narrative, which I think I've it's kind of argued isn't the case today. In fact, I'm just going to reinforce that point. ICT here has a mixture of colours. It is a mid-tier subject. ICT as GCSE is probably comparable to chemistry. It's maybe not chemistry, but it's looking actually slightly harder than maths. It's not an easy subject. It's not a subject which everyone got an A grade in, but that was the narrative, and that's what people stuck on when they asked for the curriculum change. And then you got, it still prevailed. So this is Norton writing earlier this year in The Guardian. Dad, you never guess what I've had to do today, learn to use Microsoft Word. Well, goody for Norton's son that he had to learn Microsoft Word, he already knew it. That's great, but this is the myth of the digital native. You've got many students who are not the son or daughter of a Guardian technology editor, and you need to think about digital literacy for everyone. It's not just for the elites who've got parents who have a platform to say these sorts of things. And everyone needs to have a digital education, and many kids from poor backgrounds are not going to get that, and they have been largely ignored in a conversation like this one here. And then you've got this thing again from Williamson saying that there was this this emphasis on computer science. The drafting committee put something together, but the computer science elements were kind of beefed up, and the digital literacy elements were kind of toned down at the very last minute to make a curriculum which wasn't entirely what the curriculum panel was hoping for, or certainly some members of the curriculum panel. And I'll read this to you in full. So Twining was a member of the curriculum panel who is now a professor based in Australia. But it says, I'm dismayed. Even if you take the narrow view that our school system is intended to prepare young people for the world of work, this proposed computing program of study is not fit for purpose. Most workers do not need to be able to program computers. They don't even need to have a deep understanding of how computers work. However, all members of our society need to be digitally competent, something that appears to be a minor consideration in this programming. It's this computing program of study. Pretty strong words there, and you can go back to this the theory of intended policy, actual policy, and in-use policy. The intended policy is this: it's that we're going to have digital literacy, information technology, and computer science. The actual policy document, the program of study, talks about all three things, with computer science taking up a greater element of that than the other two. So, you could certainly interpret this in a way which covers all three things very well. And the National Centre's new computing curriculum does a really good job of covering these three things very well. But then you've got the in-use policy, and it's useful to step back a bit. So we changed the curriculum because it was demotivating, university demotivating and dull, not according to me. So me has 2011 data interviewing students, female students, I think it was across London. And they say that ICT is more interesting than history and geography and MFL. Not as interesting as English, but about as interesting as maths. So they're interested by it. They enjoy it. Perceive usefulness. So they're not saying it's useless. They think it's actually quite a useful thing. It's more useful than PE, MFL, history, arts, and geography. So it doesn't quite align with what we're seeing, the government saying to change the curriculum. And also girls here, they really, from this data set, they really like data handling activities, according to me. You then go and do it does another report using data from last year, and he sees that actually data skills is the least popular thing in schools. Teachers are not teaching it anymore. So the one thing that was top for girls in terms of doing computing is now the bottom of what the focus is in schools. And why is that? Because Key Stage 3 computing is being used to prepare students for the GCSE. And this over-focus on computer science at GCSE level has, seems to be having a hugely detrimental impact on the sort of subject area which might engage girls. He also finds that computer science is not available to less able pupils, which I've discussed already, and there are limited options at Key Stage 4 for anybody who doesn't want to do the GCSE computer science course. Again, we've kind of covered this, but this is more qualitative data, so it's nice to see this kind of helping support some of my theories on this. So, all a bit worrying, and just to let you know, this raises a lot of questions for me, and there's a lot of data that does need to be collected. And one of the things which I'm very lucky earlier this week, I've just secured Nuffield funding for the next 3 years to look at these 3 research questions. So we're looking to the main predictors of female attainment. We're trying to find out, is this a case that the curriculum at GCSE is wrong, and there are elements of the computing GCSE exam system which are detrimental to female performance? It might be something which starts much earlier. One of the factors that explains schools with high female participation. So we want to go and find out, why are these schools offering it? Where are they? And what predicts girls taking computing at A level and GCSE? And we're going to try and do a little bit more longitudinal stuff. Students' attitudes and school level computing influence to take up. So my theory is if girls do really badly at computer science compared to their other subjects, not in general because they do quite well in general, but if they do badly in computer science compared to the other subjects, it's going to be very unlikely that they're going to go and take computer science at A level, for example. And we're going to be looking into that. So that's a 3-year project, which is hopefully starting in February. Okay, so everybody, thank you ever so much. This is the moment where you find out the internet connection died and there's nobody here.